Okay, so silver chromate is sparingly soluble in aqueous solutions. The KSP of silver chromate is 1.12 times 10 to the negative 12th. What is the solubility of silver chromate if we start with 1.4 potassium chromate, so, and then 1.4 molar silver nitrate, so we're done add silver, we're going to add chromate, and let's do pure water. I want to do pure water first. Okay, so we have Ag2 CrO4 yields 2Ag plus CrO4, that has a negative 2 charge, so positive 1 charge. If I do an ice table of this, we find that we start with 0 silver, we start with 0 chromate, but for every mole of chromate that we get, we're going to get 2 moles of silver. So the equilibrium concentrations are 2x and x, and when they ask you about solubility, they're basically saying what x is. Okay, we have 1 mole of this, 1 mole of this is produced, so we're looking for x. Okay, so KSP equals 2x squared, okay, that's the silver, times x, okay, and that's the chromate. So in the case of pure water, we have, this is exactly what we want. So we're starting with 0 chromate and 0 silver, and we use the 1.12 times 10 to the negative 12th equals, and we can say 4x cubed, because 2 squared is 4, x squared is x squared, times x is x cubed, and we divide everything by 4, take the cube root, and we get x equals 6.5 times 10 to the negative 5th. So this is pure water. What happens if we, I'm on a different color, what happens if we put it in potassium chromate? So potassium chromate, okay, and that's going to basically mean we have 1.4 molar chromate, okay, because this is undivided evenly, so we have 1.4 molar chromate. We do our ice table here, and we're going to see something different. So chromate, we have 1.4 molar. We still have 0 silver. So silver still changes by 2x, chromate still changes by x. So we have at equilibrium 2x and 1.4 plus x. And the thing is, 1.4 plus x, because x is so small, that basically equals 1.4. So we can take our KSP, and it's going to equal 2x squared times 1.4. Okay, so I'm going to divide by 1.4, divide by 4, because 2 squared is 4, and I'm going to get, and then take the square root, so I'm going to get an x equal to 4.47 times 10 to the negative 7. Okay? And when I take the silver nitrate, so when I have silver nitrate, okay, so I'm adding silver, and that's going to be 1.4 molar silver to my ice table. And so I'm starting with 1.4 silver, 0 chromate. I'm going to be adding 2x silver, x chromate. So at equilibrium I have x chromate and 1.4 plus 2x silver. But again, the 2x is so small that we can ignore it. So we have 1.4 over the silver. So we have 1.12, my KSP is negative 12, equals 1.4 squared x. So I'm going to square 1.4 and then divide both sides by that number, and I get x equal to 5.7 times 10 to the negative 13. Okay, so the solubility, as you can see, decreased significantly. So it was 6.5 times 10 to the negative 5th in pure water. When I added additional chromate, okay, the solubility went down a little, because basically the chromate's a 1-to-1 ratio with the silver chromate, but the silver has a much more significant reaction or effect. So if I add the silver, it decreases the solubility much, much more.